All right, let's see if we can do a real example then. Something that looks just like from an exam. Here's a hard one, okay? So get ready. This one's a little bit tough. So first we have an arithmetic sequence, and we're told the third term and the seventh term. We don't know the first term. We don't know the common difference. What? In fact, that's the first two parts. This is the hardest part, I think, is getting A and B. Okay, so after that, we're supposed to find the 10th term, then find the sum. Those will be easy once we've defined it, but it's a little bit hard. So there's a couple of ways that they like to do this on exams, so it is pretty important. What I like to do is actually just write them down like this. Put a placeholder. 3, 4, 5, 6, and 7. So this is U1, U2, U3, U4, U5. This didn't look like a 4. There we go. U6 and U7. All right, and you can keep going forever. So all we know is that the third term is 7. So watch this. I'm going to put in what I know. So I know that the third term, U3, is 7. I know the seventh term is 19. And I've got to figure out the common difference. What? Do you see, you could try guessing. If you guessed what the common difference is, add that, put that number here. Add that common difference again, put it here. Add that common difference again, get here. Add it again, you better get 19. So you could actually do it by just guessing. But there's a more straightforward way to do it. If you look at this in the right way, look at this. We can say, well, I know that that common difference, you know that little common difference that I put in here, and here, and here, and here? I know that whatever that number I do, well, I know that 19 minus 7, that's going to be some number, right? And what I know is that 19 minus 7, whatever that subtraction is, I know that that will define this thing that's been done. How many times have I done this addition here? I've had to add it once, that whatever number we have to add here. Right? So we're going to do this. D equals. See, I've added that D once, twice, 3 times, 4 times. So if I do 19 minus 7 over 4, that just may not seem so obvious. Some people really don't get this. Some people get it right away. It's really weird in a class. Some students, they get it instantly. They look at it and they know exactly what the number is. Some people really need to think about it. Whichever it is for you, take your time. If you need to write this out and just take guesses, that's also okay. But if you ever get something like this, always do the subtraction. The biggest minus the smallest, divided by the number of times you have to do your D here. In this case, 1, 2, 3, 4. That's why I divide by 4. So I could do that on my trusty calculator. So I can even put a little fraction to make it look pretty and do 19 minus 7 over 4. I end up with a common difference of 3. Let's see if that works. So we're saying that D equals 3. Does that really work? If that's the case, watch what we can do now. If that's the case, that means 7 plus 3 is, remember that's what it should be, right? If it's always plus 3, let's see if this really works. By the way, that number right there is also plus 3, and this one here plus 3 gives you 7. So 7 plus 3 is going to be 10. 10 plus 3 is 13. 13 plus 3 is 16. 16 plus 3 is 19. So this does work. We've done it right. Now, if we want to work our way backwards then, what number plus 3 is 7? Or you can say 7 minus 3 is 4. What number plus 3 is 4? 1. So do you see how we've sort of worked backwards? We can go as much as we want. See, 19, we can say 20, 21, 22, 23, 24, 25. We can go as far as we want. So what's the first term in the sequence then? I hope you can see that that's now easy. The first term is 1. So actually, that was the hardest part of the question. So now it actually becomes pretty easy. This was the hard part, I thought. It's not straightforward. I didn't think that was obvious at all. So how do we do the 10th term then? Well, we can use our trusty equation. Remember the equation. You can look it up, right? It's un equals u1 plus n minus 1 d. So if I want u10, the 10th term, well, of course, I could just keep going, couldn't I? By the way, if you want to be really cheap, look. You can say u7, this is u8, this is u9. So this right here is u10. Look. 19 plus 3, let's see, 20, 21, 22, 23, 24, 25. So that means 26, 27, 28. So notice, this right here should be the 10th term. It should be 28. Let's see if we get 28 using this math way here. So this one right here, if we do it this way, I'll do it maybe in blue instead. U10 is going to be U1. U1 is 1 plus, and it's supposed to be 10 minus 1, which is 9, times D, which is 3. Let's see what we get. What's 9 times 3? That is 27. 27 plus 1 is 28. So I know that U10 is 28. Hey, so do you see there's a math way to do it? Oh, there's the cheapo way. If it's short enough, you don't have to have like the 100th term, then you can do it this way. What's the sum of the first 12 terms? Do you remember what that means? We use our sum equation. Sn equals. If you don't remember it, no problem, you look it up. N over 2 times 2u1 plus n minus 1 times d. So in this case right here, if I wanted S12, sum of the first 12 terms, I make n 12. So 12 over 2 times the first term. Remember, the first term is 1. 2 times 1. Plus 12 minus 1, which is 11, times d, which is 3. What's that? Well, 12 over 2 is 6 times 2 plus, this right here is 33. You know what? I always like to do things by hand, but I realize you can do it on your calculator. A lot of students sort of heads go a little bit crazy when I'm doing it all by hand. Let's just do it like this. 33 plus 2 is 35. That times 6, let's do it on our calculator. 210. So that equals 210. There we go. We're done. So you can do it any way you like. You take your time. But I thought the hardest part about this question was really figuring out what to do about D and U1. If you can follow this example right here that I gave you, if you can do this one, then you are a master of arithmetic sequences and series. If you don't understand it, go back through it, take your time. You'll see that this is one of the hardest ones I've ever seen on an exam. So if you can see something like this, then you can do everything.